This is obviously a very controversial topic. As you guys know, a lot of people have very strong opinions about it. I'm well used to speaking to people who have very strong opinions, either pro or con on this topic. My role here is simply to provide the data. So, show what data we have, show how some of the data may support some conclusions or not other conclusions, and then also show the limits of the data. Okay, so I'm going to share my screen. We'll see if this works. All right, so the 5-minute introduction here is that we, as Umberto said, we wrote a 432-page report on this topic. And by we, I really mean the royal we. So this was headed up by an agricultural economist in my lab, Travis Grout. So he was employed by Cornell Entomology and also our New York State Beekeeper Tech team. So he took the main lead on sort of the overall logistics of the report and also the economic side of things. I took lead on the pollinator risk side of things, and then Phoebe Koenig, a technician in my lab, played a very large role for basically everything regarding the report. So a lot of tracking down a lot of the information and contributing to proofreading, et cetera, et cetera. All right. Okay, so neonicotinoids. Most people know this, but if you don't, they are the most widely used insecticides in the world, and they have several desirable attributes. So there's a really good reason why neonicotinoids are used. They are highly effective at controlling target pests. They're versatile, so they can be used as seed coatings, foliar sprays, soil drenches, trunk injections. They can be used in a lot of different ways, and they're relatively safe for humans, especially compared to some of the older chemistries like pyrethroids and organophosphates. So that's really important if you're a pesticide applicator or if you're a human, like we all are. We like to use things that are safe for us. But unfortunately, they also have some undesirable attributes. So they're highly toxic to beneficial non-target organisms, including pollinators. They're systemic, so they can accumulate in pollen and nectar. It's not just that they stay on leaves, on which they're applied, and then they impact those target organisms that are interacting with the leaves. Unfortunately, they get into all plant tissues, including pollen and nectar, which are relevant to pollinators. And then they're relatively persistent in the environment. So they hang out for a while in things like plant tissues, water, soil, etc. We are using more neonicotinoids in both the United States and in New York. So here are data showing you the increase in neonicotinoid usage when these compounds were introduced in the mid-1990s up until 2012, when we have really good data for this particular topic. And that same data shown here in New York. You can see there's an upward trend of usage of all the different types of neonicotinoids. And the result is that we have increased loading or toxic loading to the environment. So you're probably looking at this graph and saying, wait a minute, that doesn't make any sense. I see a downward trend in the amount of pesticides that are used here. So these are all the different types of pesticides that are used, starting in the 1990s and going up until 2012 here. And that is absolutely true. We have observed a lower amount in terms of weight, so kilograms of those pesticides over this time period. But if we express that same graph here in biological terms, so how toxic are these pesticides, all right? And let's focus especially on this blue bar, which is related to neonicotinoids, you get a completely different picture. So what you can see now is a large increase in oral toxic loading to the environment expressed as a honeybee LD50 equivalent. So those honeybees, if they're dosed with a particular pesticide, those pesticides can be more or less toxic to those bees. And it turns out that neonics are extremely toxic to honeybees. So therefore, even though there's less pesticides that are being used in the environment, because neonics have been adopted over this time period and because they're so toxic to those bees, there's a great increase in this toxic loading to the environment. All right, so at the same time, what we've observed is somewhere between about 1.25 of US honeybee colonies have died every year since systematic data started being taken on this subject in 2006 by the Bee Informed Partnership. And we also know that same story is true if you look at the wild pollinators. So just as an example, here in New York, we have 414 species of wild bees, and we know that at least 53 of those species, or 13%, are experiencing some form of range contractions or population declines. And in fact, we know that this is not just limited to pollinators. It's not just limited to bees. It's not just limited to pollinators. In fact, we're experiencing terrestrial insect declines, as is shown here in this particular figure. So this was the recent meta-analysis that was just published this year. This is now the authority statement on this topic. I'm sure there will be further papers that come out on this topic, but right now this is the most important one. And what we can show, or what the authors showed from 166 studies, is that on average, there's a 9% decline in insect biomass per decade across the world. There's a lot of variation, so the different colors here show whether that trend is more negative or more positive, from red to blue and a lot of stuff in the middle. But overall, we observe a 9% decline per decade since data really started to be taken in the 1950s and 1960s. All right, so we're obviously talking about neonics here today, but just to let you know, there are lots of reasons why pollinators are not doing well. So the scientific consensus is that it is no one factor that is driving problems in pollinators or just general insects that we're experiencing nowadays. These problems are generally classified into 5 major categories. So pesticides is one of them, exposure to agrochemicals. Pests and pathogens, especially that varroa mite, as you can see up there for honeybees, are important. Climate change is important. Loss of habitat or simplification of resources, as shown in this cornfield right here. There's habitat there, but it's only one crop and a tree in there. And then for managed bees, especially, inadequate management practices are also contributing to problems. So again, just to emphasize the point, neonicotinoids are not the only stress that's impacting pollinators. There are a lot of other stresses. But still, this begs the question, how bad are neonics for pollinators, and how much do users benefit? So like we've been saying so far, we recently wrote a 432-page report on this topic. It took us about 1.5 years to complete that research. This was conducted as part of our New York State Pollinator Protection Plan, and you can download the report for free at this URL here, which we're happy to share. If you don't want to wade through 432 pages to get to the gist of the report, we also wrote a 4-page summary in American Bee Journal. So Travis and myself wrote this, and even if you don't subscribe to ABJ, you can download this summary for free at my website at the URL below here. All right, and one last slide for the intro, then I'll kick it back to Umberto. But really the question that we addressed in this report is, what is the balance between benefits and risks? So if any lawmaker is potentially making a decision about neonics, so if there's any regulatory action that might occur, they need to be able to benefit or weigh the benefits of neonics, and there absolutely are benefits of using neonics, versus the risks, so the potentially good and the potential bad. And the best way to do this is to look at the specific application context in which neonics are used. So what we did is we made a comprehensive side-by-side analysis of economic benefits and risk to pollinators in those 5 major application contexts. Those are field crops, the production of corn, soybean, and wheat; fruit crops, so things like apple, blueberry, other fruit crops, almond if you're out in California; vegetable crops, so things like squash, pumpkin, cucumbers, tomatoes, etc. Ornamentals, turf and landscape management, so things like golf courses and ornamental plant nurseries; and then conservation and forestry. So a lot of neonics are actually used in forest settings to guard against invasive forest pests, which some people don't realize. All right, so that's an intro here. I'll stop sharing. and kick it back to Umberto.